Okay, so we're going to look at just briefly at this. Automatic time series forecasting, the forecast package for R. There's a package called Forecast, which you're going to be using. And so now let me just say that forecasting is a big subject, and time series forecasting, which is what we're doing here, you could easily spend 40 lectures on a class like this. So in our class we have a total of 14 lectures, and we don't spend 14 lectures even on this subject, but you could easily take courses where you would spend 40 lectures or 45 lectures on this subject or more. So of course we won't be able to go into the details. However, let's just read what this package is about. Automatic forecasts of large numbers of univariate time series. Remember, univariate means you just have one variable other than time, are often needed in business. It is common to have over 1,000 product lines that need forecasting at least monthly. Even when a smaller number of forecasts are required, there may be nobody suitably trained in the use of time series models to produce them. In these circumstances, an automatic forecasting algorithm is an essential tool. Automatic forecasting algorithms must determine an appropriate time series model and then estimate the parameters and compute the forecasts. They must be robust to unusual time series patterns. That means they have to be able to handle unusual time series patterns, and applicable to large numbers of series without user intervention. So you want to sort of be able to do it automatically. The most popular automatic forecasting algorithms are based on either exponential smoothing or ARIMA. So ARIMA is a well-known and important method in economics, and maybe even in probably more in economics than in finance, or more in economics than in stock modeling, but it's a very important method. So we are going to use that in our code as well, and we're going to use this package, in fact. So with that, then let's begin this chapter 5. So he says, turning to economic data, we know that there will be ups and downs, but when will the economy turn up? When will it go down? Much economic research relies on gathering economic data to answer difficult up and down questions. Economic data typically measures organized in time or in time series. So he says we're going to use United States economic data. It's going to come from the site is the Federal Reserve Bank of St. Louis. That's that FRED that we saw. We explore these data with statistical graphs and time series models. We will do models as well. We show how to use the time series data to make economic forecasts. Okay, so we're going to look at 4 examples, 4 data sets, 4 time series. One is the unemployment rate over time. The other is manufacturers' new orders, durable goods in durable goods. So how much manufacturers are producing. Consumer sentiment, what consumers are feeling. Are they feeling positive or negative about the economy? And also how many new homes are being sold. So these are 4 different data sets that we're going to look at. And maybe these all are different kinds of reflections about the way the economy is behaving or the way it's doing. They say these are often thought of as leading indicators. So leading indicators, I didn't understand for a long time, but leading indicators mean that they predict the behavior of the economy. In other words, they happen before the overall economy changes. So if they go up, generally speaking, of course not if unemployment goes up, but if employment goes up, that usually means that later the economy will be doing well. Not at the same time, but these are leading, means they happen before some other events occur. Or if manufacturers are increasing their orders, then that is also a leading indicator, indicating that in the future, not too far in the future, that things will be improving in the economy, and so on. Okay, the next thing he says is we want to change this so that it's not, because when unemployment goes up, that doesn't mean that the economy is getting better. So what he does is he takes 100 minus the unemployment rate. So that when that goes up, so that's like the employment rate, right? So when that goes up, that will generally mean that the economy is doing well. So we'll have to create a new variable in R doing that, right? And next he seems to want to change durable goods orders, which was this one, right? This was in millions of dollars, but he wants to change it to billions of dollars. So that means he has to divide by 1,000, right? So that will also have to be done in R. He says that when we plot this stuff, we're going to see the so-called Great Recession that happened whenever that happened a couple years ago, reflected in the four economic measures. They're labeled like this, 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 and this. By the way, when was that? So here's 5.1, and it was obviously around here sometime. So when is that? It's around 2010, right? Or 2009, I guess. So we can see that they all reflected that big economic change, downturn. Okay, so let's take a look at some of his code first. So first he's going to use both of these. So you're going to have to put this one in as well. We didn't do that one, but it's for using dates. And we see here that he's going to make a plot that has 4 plots on one window page. And then he's going to use this get symbols, which we just saw how to do. And this is it. And the source is here. And I'm not sure what this means, but I forget right now. But we won't worry about that right now. You can look it up. And then we're going to remember he's going to create the employment rate variable, which is 100 minus this, which I guess is the unemployment rate. And then he's going to go on to rename the second column as employment rate. Okay, so I tried to run some of this code, and again I'm getting this problem of not being able to download this Phred data. I'm not sure if the system is actually down, which is what it says here, or if there's some problem from APU. I don't know. So I'll stop this video and restart it a little later.